Hey developers, Bilal from Zenfinity.net, and welcome to another video tutorial. In this one we're going to be implementing object pooling, which we talked about in the last video. We're actually going to be implementing it in Unity as a dictionary, and we'll be able to call it from anywhere, and it's very easy to put it into any project. I know that I've been reusing this similar code for the past 2 years in all my projects. It really has had a big effect on performance. So without further ado, let's get into the tutorial. So we're going to be implementing this versatile object pooling system that we can use to pool any prefab in our project. After this video, I want you to understand the difference between instantiating and pooling, and I want you to know how to implement object pooling and be able to improve performance of existing projects simply by including our object pooling script and calling its pooling function. Now in this implementation, we'll use a dictionary for constant time complexity lookup or fast lookup of our pools. We'll be using strings as keys to get a pool by the path of a prefab, and the values of our dictionary will be lists of game objects that represent our pools. Now the beauty of this system is how easy it is to use. You can drop it in a project and change object.instantiate calls, which are default Unity object creation calls, into our own one-liner, which will be objectpooler.getPooledObject. Then we can just disable the object rather than destroy it when we're done using it. Now, before we get started, in this video we'll be creating this object pooling system and implementing it in a bullet firing example to increase performance. This example is actually from our Create Your First Game course, which is currently 90% off. You can check it out by clicking in the top right of this video on the card. Okay, let's get right into the tutorial and write our object pooler. Okay developers, welcome to the editor. And the first thing I want to do is actually go ahead and run this project that I've made available for download in the description. And what it's going to do is basically just let us fire bullets from our player. Now as we do this, I want you to look over in our hierarchy view and see how bullet clones are being spawned and then just destroyed. And again, that's an issue of performance where we can clearly improve that just by making them, instead of being destroyed, get reused by deactivation and reactivation. That can get a really huge performance impact in a game like this where we have a bullet hell. Okay. So why don't we go ahead and create our first script, which is going to be our object pooler. So name this object pooler. And we'll go ahead and open this inside of Visual Studio. And we won't be needing these start or update functions. Okay, so basically what's going to happen here is our object pooler is going to take in some sort of string as a key, and it will return us an object that we can reuse that's typically deactivated, as we're going to be using that as a flag. And to do that, we're going to create some checks, we're going to create some creation functions, and we're going to create some retrieval functions. So to begin with, we'll go ahead and make our attributes. And we only really need a couple here. So we want one that will write our default pool size here. So we'll write a private constant int default pool size, and we'll set this to 20 for now. Now if you don't know what a const is, basically it's just a variable or attribute that we can't change after compile time. So whatever we write here when we first declare that constant, we also have to instantiate it and give it a value that cannot be changed. Okay, so our default pool size is going to be, of course, the default pool size, as in whenever we create an object pool, it's going to use this value by default. Okay, so let's also create a Boolean here that will tell us if we should expand or not. So expand when necessary. And when I say expand or not, I mean whenever we retrieve an object, if our pool is too small and every object is unavailable for being reused at the time, then we'll add some more new objects to the pool by expanding, and those will return that object that we just expanded with rather than doing nothing. Okay, so let's make our next variable here, and this is going to be the kind of the meat of our object pooler. Basically, this is our dictionary. So public static dictionary string and list of game objects. And this is going to be called object pools. And it's going to equal a new dictionary of string and game object. Now, as we said before, this is going to be our attribute that's going to be storing all these game object pools by a string key. And the string is going to be the path to a game object prefab, and the list is going to be all those instantiations of that prefab. Okay, so let's put a region around this, just to keep it wrapped and organized. And region. And again, if you don't know what a region is, all it is a method of organizing in Visual Studio that allows me to collapse all these variables. Okay, so moving on, let's create a region for our object pool checks. What I mean when I say checks is that we're going to be using these as helper methods that will notify us if an object pool exists or if an object is available for reuse. Okay, so our first one here is going to be private static bool. Pool exists for prefab. And we'll give it a string as our key. And all this is going to do is check if our object pools contains a certain key. So object pools.contains key, prefab path. So all that means is that if the key doesn't already exist, it means we're going to have to add it in. Okay, so we're only going to be using this as a Boolean check, which is why it returns bool. Moving on, we're going to create a private static bool is available for reuse. Reuse. And this will take a game object, and this is typically only going to be used on game objects that are already part of a pool. So we're going to return not game object.active self, and that just means the game object has been set to active in Unity, and when we use this not operator, we're just checking that it hasn't been set to active. Okay, so I'm going to go ahead and collapse this pool check and this attribute check, and this attribute region. Just so that we can go ahead and have more space to look at our next region, which is going to be the creation of object pools. So we'll create a region here called object pool creation. And I'll put a space between object and pool. And I'll end the region here. Okay, so we're going to have a couple functions in here. The first one's going to be to create an object pool. And the second one will be to expand an object pool. So writing our first one here, we'll create a public static list of game object returning function called create object pool. That will, of course, take a string for a prefab path, which is the prefab we want to create an object pool for. Okay, and we're also going to take account of how many objects that we want to pool. Okay. So here we're going to check really quick if count is less than or equal to 0. Then we're just going to set count to 1 so that this actually does something. Okay, and now underneath this, we're going to do quite a number of things. So first we're going to go ahead and use the resources.load function to grab our prefab and say this is a game object that I want to instantiate. We'll also create a list of game objects, and then we'll basically instantiate all those objects, toss them in the list, and then we'll return that list. So it's nothing too complex. We'll just go ahead and code it out together. So game object prefab is going to equal that resources.load game object at this prefab path that we passed into the function. Okay, so like I said, we're just loading from a path into a game object that we can now instantiate here. So first we're going to create our list. Okay. And now that we've created that, we want to go ahead and use a for loop so that we create this count of objects. So let's use for int I equals 0. I is less than count. And then we want to add on to I. Okay, so in here, we're going to create, first of all, our instance using that prefab we just loaded. So game object instance equals object.instantiate game object prefab. Okay, Now, right under here, we'll add this into objects. So objects.add instance. Okay. And now we just want to set it active to false. We'll set it to inactive, basically. So in there we type false in our setActive function. And we're doing that because anytime you pull an object, when we create an object pool, we don't want this game object to be doing whatever it might, like using whatever components it might have attached to it. We want to make sure that it's doing nothing while it's in the object pool so that that object pool can be reused whenever, and we don't just have 10 active bullets flying instantly when we spawn them. Okay, so now all we have to do is add this new pool that we created, object pools.add prefab path and objects. So there we go. We just added this as a value for this prefab path key, and whenever we call this, it would be added to our object pool list. Now we just have to return objects so that if we ever call create object pool, we can just reference the list directly without having to go and reference it again from the dictionary. Okay, now let's create our other function called expand pool and get object. So this will be a private static game object returning function called expand pool and get object. Okay, and we have a string prefab path and a list of game objects that are going to be our pool. Okay, so basically this function is just going to expand whenever we grab too many objects out of our pool. As in, if we're trying to grab more objects than we actually have disabled, then we'll create a new one that we can use. Okay, so we'll check if not expand when necessary, and we want to return null. And then we want to load our prefab just like we did before. So resources.load game object using that prefab path. Okay, now let's instantiate the prefab and add it to our pool, and then return that instance. Okay, so game object instance equals object.instantiate prefab, prefab, wrong brackets, as game object. Okay, and now after this, we'll type in pool.add instance to keep it in our pool that we're referencing here. And keep in mind that this is being passed by reference as it is a list. So we can pass in a pool by using a prefab path and then add it to that specific pool whenever we want to. Okay, so now let's return that instance so that we can grab that. Okay, so that's all we need for our object pool creation here. Now we're going to want to create our object retrieval functions. So let's create a new region here called object retrieval, and we'll end this region. Okay, and so we'll have three functions here. The first one is going to be basically to find our first available pooled object from a pool. So let's actually just write that out now. So private static game object find first available pooled object. And this again takes a reference to a game object pool. So what this function will do is just iterate over our pool and find the first inactive game object. So let's write that out with a for loop really quick. So for int I equals 0, I is less than pool.count, and I++. So going all the way through our pool, we want to check for each game object. If it is available for reuse, then we want to check on that pool object. And then in here, we're going to just return pool, because that will break our for loop and it will return this game object from where this function is called immediately. Okay, and now basically if every object has been gone through here and none of them were available for reuse, we're just going to return null, which will say, we don't have any pooled object here, basically. Okay, so now let's go ahead and write our we'll make our create and retrieve object from pool. So this is going to be another function returning a game object. So create and retrieve from pool, string prefab path, and int pool size is going to be equal to default pool size. Okay, so let's first call create object pool with prefab path and pool size. And then we're just going to return get pooled object of that prefab path. Now, since we haven't yet written that function, all I'm going to do here is comment this out and return null so that we don't get any compiler errors. And now we'll write our get object or get pooled object function. And afterwards, we'll come right back to this one. So public static game object get pooled object string prefab path and int pool size equals default pool size. Okay, so the first thing we're going to do here is check if we have the pool. If we don't, we'll create the pool, and then after that, we'll just return that first object from here. Okay, so first we'll have our check if not pool exists for prefab path. Then we want to return create and retrieve from pool prefab path and pool size, which is why we had to go up here to finish our get pooled object function, because they actually reference each other. And now we'll just create a variable for our pool. So var pool equals object pools prefab path. Okay. And now game object instance is something we're about to use here. So basically we're going to use the tertiary operator here to do a sort of if-else then. So what we'll do is return instance equals, we'll check if instance exists first of all. So instance is going to be set equal to find first available pooled object of pool. So we're going to check if this is not equal to null, then let's return our instance. So what we did here was we searched for our first available pooled object and we returned it into instance. Now, if we do have a first available pooled object, it won't be equal to null, and then we'll return that instance. Otherwise, so if this is actually false and this is equal to null here, so we didn't find an object, then we have to expand our pool and get an object with those same parameters. You could also write this as an if-else then and just check if instance equals find first available pooled object, then we want to return that instance, otherwise we want to return this. Okay, so moving on, let's go ahead and finish over here and uncomment this. And now we should be all set for our object pooler. Oh, and I want to remove this null function here, or null return here. Okay, so now that we're all done writing our object pooler, let's go ahead and hop into our ship weapon script here that we've already created for you. And basically what we want to do is change the way that this instantiates bullets, or I guess fires bullets, because right now it instantiates them, but we want to change it to use our object pooler, which again we can call from anywhere, just because then we can increase our performance and illustrate how this thing really works. So up here we have a bullet prefab attribute. We won't be needing this anymore, but we will be needing a constant pointing to where our string or our prefab is. So we'll write public const, or sorry, this is actually a private const string, and we write this in all caps since it is a constant. Bullet prefab path is equal to prefabs slash bullet. Now notice we only do prefab slash since this is going to be starting from the resources folder, and when we use resources.load, it automatically figures out how to generate that path based on some folder that's inside of resources. So here we're in the root resources folder, and we're going to be moving to prefabs and then bullet. Okay, so now let's scroll down, and we won't need this instantiate function anymore. Okay, so let's go ahead and get a new pooled object here. So var bullet equals object pooler dot get pooled object bullet prefab path. Okay, now that's going to get our deactivated bullet. So here we'll write bullets.transform.position equals position to reset the position. And I'm going to go ahead and duplicate this and write rotation and rotation. And at the end here, I just need to set this bullet to active. Okay. Now before we get going into Unity, there's only one more thing we need to do, which is go into our bullet behavior here. And we don't want to be destroying this thing. We want to just be deactivating it. So all I'm going to do here is delete this, and I'm going to write gameObject.setActive false. So now this is going to toss it right back into the pool. And notice how we didn't really need to do much work at all to put our object pooler to use in our ship weapon script. And that's why this is a really nice implementation of it, because we can go and copy and paste this into however many different projects we want to. And that's actually what I've been doing for the past 2 years with a variation of this code. Okay, so let's go hop into Unity now. And the first thing I'm going to do is go to our assets folder and create a new folder here. And it's going to be called resources, of course. And I'll just drag my prefabs folder into there because the prefabs folder already has a bullet and a player here that have been pre-configured if you downloaded the Unity package in the description. Okay, so I'm going to hit play now. And what we want to look at here is the hierarchy. So I'll click and then I'll pause. Notice we have 20 bullets in here. Only one of them is active, which is the one we just shot. And the rest of them are inactive as they're part of the pool. Now this bullet will be set to inactive after its lifetime, which is 4 seconds. And every time we shoot, it'll load new ones. But then once we go too far down, the pool starts expanding. So it looks like our object pooler has been created successfully. Now, that's all it's going to be in this video. And if you want to check out the course that this ship and bullets were created for originally, go ahead and click the card at the top right or check in the description below. The course is currently 90% off and it'll teach you how to create your first game. Now, if you don't want to pay anything right now, there is also an ebook available for free download that'll show you everything you need to create your first game, and go ahead and click that in the cards up top. And with all that said, make sure to leave a like if this helped you out, and hit the subscribe button if you want to see all my tutorials that come out on Mondays and Thursdays. I'll see you in the next video.